Okay, so in this class, we are going to discuss about Kubernetes. And what are we going to discuss in the further class? That what is Kubernetes is, its architecture. We'll look into the Kubernetes lab as well. We'll do the hands-on on that one. And we'll try to deploy one application to Kubernetes. Okay, this is our main goal for today's class. Further, we will look into the namespace, pod, replica set. These are the services that we will deep dive into it. Okay, what are this? What are the other services? How this image? What are the functions, replica, template? All these things will cover into it. But before going ahead, why Kubernetes is important? Let's go a little back. Before Kubernetes, what used to be happening? What used to happen? So we used to have this monolithic application. Okay, an application in which multiple services are connected with each other and everything is dependent. Okay, the thing with monolithic services that you need to have all those, if one of these services goes down, rest all the services goes down at that very moment. So there was no proper way to manage the monolithic applications. Okay, not systematic way. Then Docker come into the picture. So what Docker says, you give me your small segment, I'll convert those into a container and one by one you can run it. So in that way, even if one of these services goes down, you still, your working application would be there and you can easily create a new container with that application. Okay, so that's how they try to deal with it. So Docker and come into the play. Okay, created multiple services. Okay, user services and the production services as well. But when it comes to managing multiple containers, again, what Docker will help you? Docker will help you to create containers. It will not help you to manage lot of containers. You can create as much as you can, but if you want to manage simultaneously on all this container, for example, one of the container goes down, you have to keep monitoring on those containers. Okay, every time we cannot do that one. That's not practical. Okay, if in the night it happens, day it happens. So you need to have someone on behalf of you that will take care of all the microservices that you're having or the container you're having to manage it. Okay, so just like Docker, there is another platform too, Container D. This application also helps you to create containers. Okay, but the most famous one is the Docker one that we have looked into it. But you should have the idea what is the other alternative for Docker, that is Container D. Okay, so whenever such problems occurs, everyone used to think, how can I manage all these containers simultaneously together? What are the possible ways? Okay, because you cannot assign someone 24 into 7 to check your containers all the time. So in that terms, Kubernetes come into the picture. Let's see what is basically is. So it developed by the Google. Okay, there was no specific purpose to develop Kubernetes. Initially, it was not even Kubernetes also. Okay, but right now it is open source container orchestration tool. Orchestration basically managing the all your containers. Okay, developed by Google engineers. Okay, helps to manage containerized application in a different deployment environment. Okay, every container would be containing different environment because those containers are made up of different images, and all those images having certain configuration, certain different types of layer. Okay, so that's why in different deployment environment, if you want to manage your containerized application, Kubernetes comes into the picture. This is the official definition. Okay, Kubernetes is a portable, extensive, open source platform. Blah 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 blah. A lot of things. It is also known as K8s. Okay, Kubernetes also known as K8s, and over 15 years of Google experience running the production overload and scales, best of breeds ideas and practical from the community. So, after initially it was like this one. Okay, Borg. The project Google engineer was working on was the Borg. So later on, they converted this Borg into Kubernetes, okay, and make it a open source. What is the meaning of open source? Vishnu, would you like to try?
Okay.
Yeah, what is the meaning of open source?
So like
Any idea? Mm-hmm.
so it's like anyone can use.
Anyone, any application can be used by anyone. What is the difference between open source and organize or a particular organization application?
Um, no, no idea.
So basically, Supriya, would you like to try?
It's free. I mean, uh, it is available for free to everyone. You know, everyone can give their inputs there. It's available for
Hmm.
every.
The second point is way more important than the first one. It's free, that's
Mm.
true. Okay. But whenever any technical person is asking you, they'll not ask you about the cost management. Rather, they'll ask you the technical answer of this one. So,
Yeah.
open source means anyone can contribute to that project. Okay. Even I can contribute to that project. So, I'll just take that project locally, change something on it, and push those changes as a PR. If the developer or the organizer of that project would love my changes, they will accept it and implement in their project, and that will be a great plus point for your resumes. So like Python is open source, Apache is open source, Kubernetes itself is open source. So you can take it locally, find the bug or anything, and try to do some changes on it. You can find. So initially it was a Borg Google private project, okay, but later on they experienced these problems are coming in almost. This problem is very much common and general, so they made it public, and the name was given as Kubernetes. So what is the benefit of this tool? That it is high availability, no downtime. Why no downtime? Because it is managed by auto scaling process. There is a process named as auto scaling. So whenever there is a huge demand, it will scale up. Whenever there's low demand, it will scale down like this. Then scalability or high performance, again the same thing. Disaster recovery means you can have the backup and restoration. So these backups and restoration will look further. Okay. So if you see in a bunch Kubernetes, there is a one master node which controls some worker node. Okay. Your container will always be deployed on the worker node. Okay. So here is the Docker container which is deployed on the worker node. So based on the configuration of your node, there is someone, this master node, decide which container should get more number of which pod. These are known as pods. Okay, small pods. Which pod will get more number of container to manage it based on the configuration or the handling process. That is known as load balancing, which we will also look. Okay. Okay. All these things are basically done by some manifest file, YAML file. It used to happen. A YAML file is there, okay, and all the necessary things you have to write in the YAML file. So basically, it's a key pair value type of. These are the keys. Okay, replica means one. Always remember, its indentation is very important. If I want this app to be of this match label, I have to put indentation after match labels. Okay, so this app and tier will belong to this match lab. Okay, same goes with the template specs. Okay, we will look more deeper into this one. No need to worry. So earlier there used to be a single YAML file which used to manage all those things, but later on what happened? They changed everything. And what they changed, we'll look into the architecture. Okay, and this architecture is very, very important. So this architecture basically contains two things: your master node and the worker node. Okay, master node also known as control panel plane. Okay, and responsible for Kubernetes state. What is the meaning of a state? It means if the node is running, stop, or not functioning well, these states are being managed by this master one. Okay, because all the containers are inside our worker node. So responsible for workload of running the container. Your worker node always responsible for running the container, whereas this master node responsible for the state of this worker node. What is the health status of this worker node? This will be decided by this master node. Okay. Any confusion so far? Anywhere?
No, Akash.
Okay. If I go a little fast, please tell me, okay? And this is the full-fledged Kubernetes architecture. Okay, let's start. Okay, so there is a user interface from which a person interface. Basically, it's always in the form of CLI. So this CLI is being covered by kubelets. So whenever if you want to write any command of Kubernetes, you need to start with kubectl, okay, or kubelets, whatever. These commands first implement goes to the master node, okay, and this master node contain certain services like API server, scheduler, control manager, and etc. What are these? We will look more in detail. So this is the master node which contain these services. Okay. And similarly, we have two worker nodes. So these worker nodes, a kubectl command basically comes here and decided by this master node goes to here. Okay, kubectl or kubeproxy. These are then are running the Docker command, which basically the Docker container you are having in one in every pod, you have certain number of containers. So these Docker containers are being controlled or command by this kubectl, kubelets. So these gives the command to the Docker and then Docker provides the information accordingly. So this is the full-fledged version. Let's look one by one what is the work of each API server, scheduler, control manager, and etc. So first node is the virtual machine. You have a virtual machine, which is basically the main server one. Okay. Control plane, which is the your master node. Okay. This master node is then get connected with multiple small nodes. Okay, which are known as worker nodes. Okay, mostly just referred as nodes. The upper one, master node, is referred as control plane. Okay. What happened? Our kubectl command, that is the node agent, is always established on this in the form of kubelets in this node. So whenever kubectl give command, this kubelet receive those commands and perform action accordingly. So kubectl give command to kubelets, kubelets perform action on what? On those containers which are available on their nodes. Okay. Someone got disconnected. Oops, Supriya got disconnected. Let's just wait for a minute. Vishnu, any questions so far?
No question.
Okay. I don't want to directly jump into the lab section until you get the idea of this whole architecture, how it functions. So it's some bit of theory section. So please bear with me. Let me just check with Supriya. Okay, let's continue. So what is the working of this control panel that we have discussed? This master node is basically for running the K8 process, that is Kubernetes process, which basically applies on these nodes, okay, which node is working and which node is not. Let's look what is pod, okay. So if you see, these worker nodes are basically running certain containers, okay, and these containers are basically run on pods. So pod is the smallest and the basic deployable objects in the Kubernetes. If you want to deploy something, pod should be there and there, okay. You cannot deploy container directly. You have to create a pod and then put the container inside it and then run that pod or deploy that pod. And pod consists of one or more container. If it contains one more, if it contains one, it becomes the smallest one. Okay, great. Let's see. These are the 4 things that we discussed so far: API services, scheduler, controller, and etcd. What is this? API 1. So the user interface front end part of Kubernetes is all API service handle. Okay, Kube API handles. So the front end of the Kubernetes is control panel. Okay, all the changes go through this API. So whatever the changes or the command that you are giving first comes to this place, API services server, and then it goes further. So it looks like this. Your UI, there it is. API server, entry point of the entry point to K8's cluster, UI part, API part, and CLI part, means command line. All these things are controlled by API server. So the very first thing comes is the API server, which controls your user interface, API, and command line. Then comes your scheduler, which basically assigns a pod to the worker node. Based on the CPU system architecture and the policies, which pod should get how much container is decided by this scheduler. Okay. So if you see this scheduler, so ensures a pod placements. Okay. If 60% is used by this one and 30% used by this one, so the next container coming in container would be deployed on this 30% used pod rather than 60% used pod. So this is ensured by scheduler. Okay. And then after comes our controller. So controller basically accounts the factor which it will see what is the CPU usage, what is the system architecture, and what are the policies. Basically, all the incoming traffic is being controlled by this controller. So the keep track of what is happening in the cluster. So who is coming, what kind of a traffic is coming inside, everything is managed by this controller. And then comes our etcd. It's kind of a database, you can say. The cluster config data saved to. So whatever the configuration you have, all those configuration get stored in certain place that is known as etcd, a distributed key value storage that controls node can access. So if that configuration part, based on this configuration, whatever node you want to access, they'll be allowing you. If your input is not matching to the configuration data, it won't allow you to access these nodes. So that's all about the API servers. Okay. Basically the master one, API server, control manager, scheduler, and etcd. Any question in these 4 services? Vishnu?
Mm,
Yeah, what question?
no
Any
question.
question?
I'm just
Okay. That's cool. Okay. So this is the whole architecture that we have seen. A control panel is there, a virtual network between them, okay, with which we are able to connect with our nodes. Okay, so this virtual network creates one unified machine. Basically, the network established between the control panel and the nodes is done by this virtual network. That's the internal network which handles by Kubernetes itself. And your worker nodes again contain the 3 parts: runtime, kubelets, and kubeproxy, which gives command to your containers which are inside your pod. So always remember, you should not have a single master node. Okay, in an organization, you do not have a single master node. Rather, they make up a backup master node. Because the thing is, if your worker node is destroyed or get hampered, or any malfunction happen to this one, they can be replicated and can be bring back. But if something happened to your master node, that is the control panel, all the new worker nodes underneath will get destroyed. So you, to protect yourself from such condition, you should always have a backup, basically the copy of that one. Okay. It is much more important than copying or having the replica of your worker node. you should have a replica of your master node as well. Okay. So there are a lot of components, out of which two components we will see today, that is the service and the deployment. Okay, how do we deploy our application on Kubernetes? That we will look today. So pods and manifest, a lot of things is there. Okay, this is the whole bunch. Two containers having a shear volume between them, deployed on a certain port. Okay. So before going ahead, we'll just cover two things with which we will be interacting. Okay. We covered this one. Small pod is the smallest part. Okay. So we almost covered this one, but let's see again. The smallest unit in this one, abstract over the container. So the container always goes inside this pod, always remain inside this pod. Okay. Usually one application. In general, you should have one application per pod, but you can have multiple application as well. That's completely fine. There is a term known as ephemeral, okay, which basically means that if one of this worker node, okay, get destroyed, so you should have a backup got created. Okay, anytime anything can be happen to the worker node based on the kind of overlapping or anything network issue, it can be destroyed. So this situation is known as ephemeral. So this is just a small term. Okay, just remember this one. So the moment it get destroyed, a new one replicate this pod with a new IP address. The moment and it get recreated. So this is being handled by your control panel, control plane. Okay, basically the master node. Okay, just give me a second. Let me make some more. So this is just manifest.yaml file, which we will look in just a couple of seconds. So right now I'm not going into the depth of this one. Okay. Deployment and replica sets. So basically you should not have pod manifest file. This used to happen earlier, but nowadays we have different services. For example, two services we will be using. First is the deployment. Okay, the deployment allow you easily manage the pod, which is very much important one. And if you want to replicate your pods or scale up or scale down, that is roll out or roll back, is done by this deployment services. And this look like this. So basically you have a deployment in which we have three replicas. So three pod will be created. Okay. So if one of the pod is get destroyed, all the items of one pod transfer to the other, or another pod will take place of this pod having the same configuration. So you never need to worry about your pod destruction or anything hamper to your pods. And the other thing is the services, which basically establish a network between your application. So whatever the other part of your application, if you want to establish a temporary IP address, is being given by these services. Okay. It also handles the front end part, that we will look how we will create the front end through our services. Okay. So user actually connect with the service, and this service target to the IP addresses which have the common tag, that is tire equal to front end. If these two pods having the same labels, then this service will attack or a kind of a redirect your traffic to these two pods rather than this pod, because the label is different. So label is one of the keyword that need to be same across all the connected pods. Okay. And this is the YAML service YAML file looks like. We will look into this one later on. Okay. Hello. Hello.
Yes, Akash.
Yeah, so we
Yeah,
covered
sorry, I
little
was
bit
on
of
the call,
things.
so.
That's okay, no problem. You will get to understand everything, okay? Or you can
Uh,
revert back the videos.
okay, okay, sure, sure.
So there is a one term while creating the Kubernetes pod services, which basically provide the permanent IP address to each of the pod that you uses. So that the life cycle of pod and services are this one. If the life cycle and the pod services are not connected, this service connect them through certain network, and this network task of connecting them is decided by this service. So there is a YAML file that we develop which creates the service between the multiple pods that we will create, so that if any of the pod get destroyed, other one could come and replicate the same one. Okay, so initially, if you do not do that one, if it is not connected, then you won't be able to recover. If it is connected using the service, then you can easily recover with the service YAML file. Okay, so it provides you this front end part with which you can do the local testing of your application. We will do the in just couple of seconds. Okay, how our application would look like. So it will provide you this one, a URL, a temporary URL, in which you can run it on your local and see your application is perfectly deployed on your Kubernetes or not. Let's go to the lab and do it. Okay. But two things before going to the lab you need to see. That is the Minikube. Okay. So Minikube is the way. So basically Minikube is a way with which we will handle all these things. Okay. So multiple masters and worker node is being controlled or managed by the command Minikube. So Minikube is again an open source platform which help you to manage your control plane, basically the master nodes and your worker nodes. Okay, to test everything locally. So earlier, if the basically it's very hectic part if you do not have Minikube to manage this. So it became very hectic to manage every master nodes and the worker nodes. So for that purpose, Minikube come into the picture, which basically binds everything into a single one, and you can do your operation using the Minikube. And do the local testing, like it comes with a Docker installation, pre-installed Docker in its uh, inside this pod or worker process, worker node. But remember, worker node is having Docker installed underneath it. Above all, you have to install Docker as well for your container or creating a container which will be getting deployed over it. So we will look into the prerequisite as well. And the other part is a kubectl, which basically provide all the commands to run your services. Okay, let's begin now. Let's start.
Akash, instead of
Yep.
Minikube, can you explain us EKS? Basically, this would be in the local, right? Instead, you can show us in the EKS. That would be better.
We will do that one also. Okay, right now everything is configured in this. I wanted to show you the production level. Okay, EKS is more of a cloud oriented. So when I'll be taking the cloud class, 2-3 days class will be go where we will cover the main part EKS. And so if you will be understanding this one, you can easily understand the EKS as well. So that's why I took the hard class first, and then later on when we'll deal with this cloud, so we can easily deal with that one. Okay. I need to develop
Oh,
that infrastructure on my cloud. So for now, we'll be going with this one. If you understand basics of this one, we can easily do it or replicate those on EKS. It won't be that much hectic at that time.
oh, okay, Akash.
Okay. So you should have the proper idea of both Minikube and EKS. I'll be covering that one too. Let's start. Okay. Kubernetes. So the same app that we created a Docker file in it, okay, and we were having problem while pushing this Docker image into our Docker Hub. So what was the issue? I'll just go. Right now, if you see, currently I have a Minikube installed, so I'll just delete this image for now. Okay. No container, no volume, no image. For now, we don't have anything. Okay. So to install Minikube, just go to Minikube. Click on this one. So you can see, welcome to the Minikube. Okay. It's a documentation part. Minikube installation. So if you see, they require a certain prerequisite is there, 2 CPUs should be having. So in cloud, you cannot create a free tier account for creating EKS account, because for Kubernetes, it will be requiring T2 medium at least. So they'll be charging you some amount for that one. Okay. 2 GB free space, 20 GB of free disk space, and proper internet connection. Plus, you should have a container management tool, which is a Docker, Helm, or HyperKit, any of the things. So we will be going with the Docker that we have studied. Installation is pretty much easy. You go to Windows, x84, stable. I would suggest you go with the chocolatey if it is Windows. Linux, it's easy. You can go and implement this curl command. MacOS, if you have, go with the binaries or homebrew. So just copy this one, print in your CLI, and it will download it. For now, I'm just going on Windows, okay, through Chocolatey. So it's very simple. You can download Chocolatey easily. To download Chocolatey, Chocolatey is a package manager which helps you to download a lot of applications. Okay. Just click on get started. So it will provide you this one. Choco installed. Okay, if you have Choco, then only you can do it. So I'm not getting right now. Okay, but if I'll find, I'll just put on the chat box. I don't want to waste time right now. Sometime they appear anywhere. So there's always some certain changes going on. So they provide a file or a command which you just copy and put it on your command line, basically the PowerShell. Okay, and if you do Choco, so they will let you know that chocolate is being installed. Okay, so I have my chocolate installed on my system, and then go to the Minikube, and if you just do this one, copy Choco install Minikube, right click, press enter. So it says installing of the following package. This one, by installing, you accept the license and all, and you can see the Minikube is being installed, which I already installed previously. So it's already showing it's already installed. Nothing big deal, just copy in this one. So if you want to check whether Minikube is installed perfectly or not, just type the command Minikube start. So it's pulling the image of Minikube, okay, because Docker is already inside this Minikube. But to run the Minikube, you need to have an environment of Docker. So make sure you have Docker in your system as well. Previous class we have installed Docker, so I'm supposing I have Docker in my system. It's taking a couple of time. So once it get the image of this Minikube, you can see on your Docker desktop that the image will appear once it gets installed. So they have installed two images, Minikube. Okay, both are coming together. That's perfectly fine, no issues. Creating Docker container. Okay, it's the very best thing. So you need not to go for your own. It will create the two CPUs and rest of the things. Any confusion in the installation part?
No, Akash.
So two things only you need to take care. Chocolatey you need to have if you're having Windows system. Chocolatey you need to have, and then after Docker. These two things if you're having, you are good to go. It's preparing Kubernetes. Okay, on the Docker version this. It's pulling out the images, and now we can go to our Docker desktop, and we can see the green light is there. It means it runs some container. So Minikube container is now in the running state. Okay, and it should be keep running state until you deploy your image into the Kubernetes. Now let's go to our project, the previous one which we were facing problem while pushing into the system, pushing into the Docker Hub. Let's go inside that one. CD the colon. So it was CD tutorials. And if I do dir, I can see all the files. Okay. Remember to create the Docker image, you need to be present. Your Docker file should be present on your root directory. Index.html and Docker file should be in the same repository. Okay. So right now we do not have any image. Okay. So if I do Docker images, so the two image is of Minikube, not of the our application. So let's create the image of our application. So what was the command? Docker build -t username AVA29, and what is the name of our application? Let's give it a name, my new app. Okay, remember the one thing from the previous class, always go with a small case. Okay, this is built in a such a way Docker that they do not accept any other case, just for the proper handling of the containers images. They prefer only go with a smaller case. And what you do, then you put dot means all this directory would be converting into this into your app, and press enter. Okay, so image is done. If you want to run it, you can. Right now I'm not going to run it. I'm directly going to push it. Docker push image name was. Okay. Earlier it was not able to push because we were not giving the username. So that's why by default it was taking what name? The library, default library, and that library we are not allowed to push. That's why it was giving the issues. So we can directly go to our Docker Hub. Docker Hub. And we can see AVA29, my new app, is now available on our system. With what is the by default tag? Latest is the by default tag. It has been given. Okay. Any confusion so far? Pushing the images. So you can also use this image. It's public. Okay. You can copy this image and put on your own system and run your applications. Perfect. Any confusion so far?
No, Akash.
Great. Now what are we going to do? For creating Kubernetes application, you need to have 2 YAML files on your system. Basic tools, that is the deployment, okay, on which you will deploy your pods and all, and then services which will interact with the UI interface, which will help you to interact with the UI interface and your deployment pods. So these 2 dots are being connected by this service file. So 2 YAML file you required. To check, we have Minikube, Minikube status. So this is just a host is running, kubelet is running, API server is running, and kubeconfig is running. These are what? These are the control plane, basically the master node. Okay, you can do kubectl pods. Kubectl. Okay. Okay. Right now there is no space. kubectl pods. And no worries about this one. I've created a separate one. We can just go to the documentation and check everything. So we can look into kubectl get pods. No resources found by default. Minikube start. Okay, no issues. Kubernetes documentation. And I created a separate file as well. So if you have any further process, you can check this documentation. It will help you. So we have done Kubernetes start. We check the status. It is in the running status. So far, we have no pods is running. So that's why it is showing. It showed us where it is. No resources found in the default namespace. We don't have any pods created yet. Okay, when we will create pods, we can easily see it here. Now, in case of the application, you need to have the Docker file, which we done. Okay, we built the Docker image creation. Okay, and we pushed it as well. Now, what do we require? We require 2 files. One is the deployment YAML file, another is the service YAML file. So we can come here and you can check deployment. The center. So it will give you an example one deployment file. Okay, you can just copy this one and let's go to our project. This is our project. I'll open this on VS Code. Okay, you have to create a file name as deployment. You can give any name, but I'm going with the standard name and paste that code. Oops. Okay, let's understand this one in every segment. What is this API version, kind, metadata, spec, basically the specification, replica, what is this replica, template and specs. Let's understand everything one by one. Are you guys with me? Any confusion so far?
No, Akash.
Okay. So let's understand this one by one. This is the, okay. Mm. Okay, so we have this deployment configuration in which API version basically gives the version of your apps. Whatever the application you have, it gives a certain version to it, which is version v1. Okay, then comes your kind. Kind basically says what file it is. Is it a deployment file? It is a service file. So right now we have a deployment file. So we have given the name deployment, okay, which basically the blueprint of the pod. So all the pods will be created from this deployment one. Okay, in this deployment, we create the pods. And then you can see we have this template section on our this deployment file. Okay, I'll show you real time as well. This is the image of real time. So basically this template contains metadata and spec which says about the pod. See, we have two metadata one, spec one. Again inside the template, metadata one, spec one. Okay, which means the copy of this one would be created a new container inside your deployment one. So you can replicate this one as much as your time and you can create your own 2, 3, 4 application like this one. So the template configuration of the pod has its own metadata and specs. Okay, so this metadata and specs of template is being created in this deployment file, deployment.yaml file. So always you need to create, if you are creating this template, need to be there if you are creating pods in your deployment file. Okay, basically deployment is for the pod. So you need to have this one. That's why it is given in the example YAML file as well. So they are making an app having the label as Nginx. Okay, the image name is Nginx, this one. Okay, and the container name, container image, port number, it is being given a port number of 18. Okay, the other part is the spec, basically the specification, where you mention the containers. So far I'm going to establish one container on it. With that container will contain a name of your application. Image name is different than your this name. So always remember this one. And the port on which your application is running. How will you get the port? See the Docker file. In your Docker file, you have expose command, okay, in which you exposed your application on a certain port number. So you need to have this one. And then you will get the labels. Okay, the use of this label, that this label will help you to connect with the pod. If the name of this label is changed, then you won't be able to make connection between your pods. Okay, so you can see I have given the description over here. You can give k8's component a label. Okay, basically a key value pair which are being attached to each other. Okay, identifies which should be a meaningful and relevant to the user. Okay, so any name you can give to the label, but basically we go with the norms that app should be the one. But if you are making for the backend, you can write tire. If you are making for the production, you can use env. Okay, you can use any of this as a label. So label do not provide the uniqueness. It help us to replicate or establish a connection. For example, all the pod replicas will have the same label. So if you see the replica 3, so 3 pods will be get created having the same name level. So that if one of the pod get destroyed or deleted in the future, the same replica can, this auto scaling would create the same one using this label. Okay, if you have different level, then it won't be able to create it. So if you see the last line, connecting the deployment to all the pods. So the deployment is being connected with the all pod using this label section. That's the main use case of the label. Any confusion in the label or any part of this YAML file so far? There might be little bit, you need to go through yourself too, okay? But for now, if you have any confusion, like, could you please explain anything, any of these services that you have not understood?
Clear, Akash, it's good.
Okay. The other part is the selector. So selector is a match label, okay, that matches with all the pods available, whether all pods having the same label or not. Who will manage this one? So selector manage this one. So if two labels, you can give the name different labels, okay, but you won't be able to have established connection between these three pods. So to manage the labels is being right one in all three pods, the selector come into the picture, which the name itself says match labels, and it matches the label with the, if it is Nginx, it should everywhere should be Nginx, okay, like this. So which pod belongs to the deployment, this is being decided by this match labels. So if match level is different, pod tag is pod level is different, it won't be able to establish connection. So the service one will come later. So let's go, and we have to do little modification on this one, okay. What is the name of our application? So I'll name my new app. I'll copy this name. Okay. So instead of Nginx, I will give all the labels a same name. Okay, to establish the connection. 3 replicas we are going to create. It means 3 pods will be created. Right now, we are not having a single pod. And container name. What is the name of our container? My application name. Okay. But what is the image name of our container? So in that case, you need to copy whole. This is the proper image name. So what this deployment will do, deployment will go to the Docker Hub and check for the image that you provided. Control C, Control V. And you can provide the tag as well. What is the tag? Latest. Okay. Port number 80. Remember, in our Docker file, we can check. See, we exposed to port 80. So that's why here it should be port 80. Okay. And just save it. Any confusion? Pretty simple. Nothing big deal. So the front end part, sorry, the pod part is being created and it's ready to deploy. The other thing, the one more file we need to create is the service. Service.yaml file. There are 2 extensions of YAML, YML or YAML. So you can use any of this extension. Let's go here and let's search for SCRDS service. So you will get the basic template from here. Just see, I'm getting this one. I'll just copy this template, put it on my system, paste it over here. Okay. API version v1 we were given kind. This kind will tell that this file is a service file. Okay, metadata, name of your app. What was the name of my app? Okay, my new app. So what is the difference is here? Selector always keep it app only right now. Okay, to match with our labels. Right now, if you see in the deployment, everywhere it was app. So service one should also contain the app name. Okay. Port. Okay, so this port on which you want to let's this one is only different here. Okay, rest everything is same. Metadata kind, API version and spec is same, only this port part is different. So let's just see it quickly how it looks like. So this is the service. Okay, kind basically tells what type of file you are going to use. Name, any arbitrary name you can provide over here, basically the app name. That's the most suitable one. Selector. So selector is a pod forward request. So it should have the same name as your pod name. Okay. Then comes your port, which is only thing different from the deployment one, deployment YAML file. Port, a service port. You can have any port on this service port, but the target port should always be the container port on which your image ID or images being given. So we remember that our images was on port 80, right? And this port we can change, we can give any port. It's on your wish. Okay. Just like the previous one we used to do in Docker file as well. Port mapping in the Docker. So container port will remain the same. Okay. Target port you can change. So our target port is 80 on our Docker file. This always has to be the same. This port you can change, give any port number. So for now I'm keeping 8080. Okay. You can keep any and just save it. That's it. These two files are created. Now you need to run your command. Okay. So what are those commands? Let's see quickly. We created our Kubernetes configuration deployment.yaml file, and we created our service.yaml file as well. Now there are certain challenges, YAML indentation error, because these are YAML files, so be clear with that one. Okay. Now, directly you can go and run kubectl apply -f deployment.yaml file. Okay. kubectl apply -f deployment.yml file. Enter. So it will say that created. It means our deployment is got created, which means pod is now being created. Okay. So if you want to test it, there is a test. You can just do kubectl get pods, the one that we did earlier. So previously we were getting none, right? No resources found in the namespace. Now we are getting 3 resources. Can any one of you tell me why 3 resources, why 3 pods got created?
Replicas 3.
Correct. Because in the replica, we've given 3 replicas. Okay. So the same pod got replicated 3 times. Okay. Now we will create the service.yaml file. Okay. It is also being created. Now to check whether the service.yaml file created, okay, we need to get the URL, okay, from this one. So this will provide you a temporary URL, which basically says whether your app is being deployed on Kubernetes or not. Okay. So we are getting one error. Can anyone of you tell me what is the error? The error is this web app dot hyphen. So our app name is not web app 1. Our app name is my new app. That was the my new. Okay, it run and it is giving you one URL. Just copy this URL. Okay, go to your browser and paste it over here and enter. Bingo. Your application run. It means we have successfully containerized our application on the pod of Kubernetes. Okay. So we have our application done. So that's all about the initial phase of knowing the Kubernetes, the architecture, the deployment of our application on Kubernetes services, okay, using the Kubernetes command, and the deployment and the services, 2 of the services we have used. Any confusion in this whole class anywhere?
Akash, this target
Mhm.
port is a container port and this port is a service. I mean,
Service port, correct.
yeah,
You can change
okay.
this port as well. Whatever the port you want to give, you can. But this target port will always be the same that you have for the image ID. Okay.
So
And that we
basically,
can.
we have different services, right? Like
Mhm.
node port or so this points to the what kind of service? It's between the containers.
Which one you are saying?
This port 80.
This port. So
Mm,
this is the service of your image ID. So the image that you are getting in your the deployment one, this image. So this image must be established on a container port you have given. Okay, initially while creating the Docker file, you expose your. Is this
the
your
thing
question?
is, like, we'll have different services now.
Mm-hmm.
So, what exactly this service is? This is a default. So, what this actually does? There is a service, node service, and load balancer, right?
Correct,
Service
correct.
will be of types. So, how
So
exactly you
this
can represent this
service,
port?
yeah, this service is basically for the front end part. Okay, so if you want to publish your application locally, for that
Mm,
part we establish this one. Okay, for the testing purpose, whether our application successfully deployed on the pods or not. For the
okay.
other applications, like when you have the database, lot of things configuration file, you need to
Mm-hmm.
create config.yaml file. Okay, we have different services. Okay, like this
Okay.
volume.yaml config map you need to create, secret
Okay.
file you need to create. These
Okay.
all are YAML files. Okay, you need to create for every type of services that you have in your application.
So
So
you
if
are
it is
going to
database,
show us a basic, like
yes,
this is just a
right
Node.js.
now
So yeah.
we
Mm-hmm.
have the very basic one. Okay,
Mm-hmm.
where database is not being used, no further things, a simple HTML CSS JavaScript file which
Okay.
be established, okay, for the foundation and understanding. In the next
Okay.
class we'll go a little bit more deeper into this one.
Okay.
Okay, where we'll take a complex application where database is there and we'll try to establish, we'll create a config, we'll create a secret YAML file, and then we'll establish connection between them and try to run it on our local. Okay,
Okay, Akash.
any further questions, Vishnu?
That one, can you explain on EKS, Akash? This basic thing, like the basic is fine, but at least till
Mm-hmm.
that point, can you set up any EKS and show us how it actually works with database and all, connections and all?
So the next class you want to be on EKS, right?
Yeah, basically
Mm-hmm.
Minikube, like they usually ask us for the high end, right? The EKS
Yeah, yeah.
mostly. So
Mm-hmm.
yeah, that would be better if it is a database connection and a front end with the EKS.
Mm-hmm.
We would be it would be much more easy for us to like to give an interview at least to know less. We know the
Yeah, yeah,
service.
that's totally fine. Because what I was about to do, if
Mm-hmm.
EKS I would be taking on the later on classes, but I was thinking to establish MongoDB database server. Okay,
Mm-hmm.
Nginx is our this one Apache type of server. Basically to run our web applications and establish connection with our MongoDB database and all. But if you want EKS, we'll try to go with the EKS on our next class. Okay.
Yeah, like I could give my Amazon account as well. Like, I have 600 credits or something like that. If you
Oh
like,
yeah, that will
you
be
might be
create me
having, but
an
anyway, if you need, I can share
yeah
my username
create
and password.
yeah that will be helpful for me.
Yeah, all right.
So
Okay.
just create I am user. You know how to create?
I am user. Yes, I can create.
Okay, it's not difficult. I have video on that one on my YouTube, so you
Mm.
can go and see from there as well. So
Okay.
create a I am user. Give me the admin access. Always I'll be you will be
Okay.
the root
Okay.
user. I'll be the I am user.
Yeah, yeah, you can use it anyways. Yeah, okay.
Okay then.
I'll do it and send
Okay
you the
then.
credentials.
Yeah, sure. Okay. That's all for today's class. Any further question? Try on yourself. Okay. Try by yourself. I'll share this
Uh,
document as well. because this document contain if any of the things even fail, what are the challenges you can have and how you can deal with those challenges also. Because in the
Okay.
my initial days, I faced a lot of challenges, even for the installation purpose as well. And then after I documented everything so that in future I do not get any problem with this one. So I'll share this doc
Okay.
with you. YouTube channel will be available with you. Anytime you can refer. And any question, just ping me on WhatsApp. I'll be always available to reply you.
Sure, Akash. Yeah, thank
That's
you.
all. Okay. Vishnu, any question?
Mhm.
Okay, good. So we wrap up here. Okay, guys, thank you for your cooperation, and let's meet on our next class with something new. Okay, see you.
Okay, Akash.
Have a great day. Bye bye.
You too. Bye-bye.